Welcome to Lesson 8, the Order of Operations. The order of operations is an agreement that was made by mathematicians way back when on the right order and the correct order in which we evaluate in math. So they sat down and they came up with this order, and we all adhere to it so that all answers come out the same. So what is that order? So many of you have heard of the phrase PEMDAS before, but I want to go ahead and focus on how I have written PEMDAS for you and the way you should write it in your notes. So the P represents parentheses, which doesn't just mean parentheses. It could be parentheses or really any kind of grouping symbol. Anything in a parentheses or a grouping symbol needs to be taken care of first, meaning you should be kind of putting your eyes towards that grouping symbol and trying to work on the operators inside that grouping symbol. Next, you want to take a look at any exponent values, any numbers that have a base and a power, and you want to take care of those before you do any multiplication and division or any addition and subtraction. Next, you want to make sure that you're multiplying and dividing before you're adding and subtracting, but you multiply and divide from left to right. So that means it could be multiply, divide, or divide, multiply. And the absolute last thing you should be doing in the order of operations is addition and subtraction. And just like multiplication and division, addition and subtraction is also completed from left to right. So it's either add, subtract, or subtract, add. So let's add some more examples to our notes. So some examples of grouping symbols that you'll see, you'll see parentheses, you'll also see brackets. Absolute value sticks are grouping symbols as well, where the problem inside the absolute value must be done first, and then you'll take the absolute value. You've actually done some like this before. A fraction bar is also a grouping symbol, where you will take care of the numerator and then take care of the denominator. And then the last thing you would perform would be the division. Exponents are numbers that have a power and a base. So for example, if you have a problem like 2 plus 3 squared, that exponent of 2 belongs to the base of 3. So technically, that's not a 3. That is a 9. So the exponent must be completed before anything else could be done. Then you would add 2 plus 9 to make 11. An example of multiplication and division from left to right would be like the following. Let's say you have the problem 6 divided by 3 times 2. The order of operations put division and multiplication on the same playing field. You do not do 3 times 2 and then divide by 6. That answer would be wrong. You would follow the order from left to right and do 6 divided by 3, which gives you 2, multiply by 2 to get 4. Again, you are tempted to multiply and then divide by 6, but that would mean that multiplication would come before division, and that's not true. They're on the same playing field. The same is true for addition and subtraction. So let's say you have something like 6 minus 4 plus 3. You do not add 4 plus 3 together and then 6 minus that. That answer would be wrong. Since adding and subtracting are on the same playing field, we follow it from left to right. So we would be doing 6 minus 4, which gives us 2, and then adding 3 to it to get 5. Now that we've reviewed and overviewed the order of operations, let's look at some expressions that need to be evaluated. In this first example, we want to start training ourselves to underline pieces of the problem that need to be done first. And tell yourself what operators you have. In this problem, you have addition, division, and multiplication. Here the parentheses are serving as a symbol to show that 3 and 2 are multiplying. So, since we have division and multiplication here, this needs to be completed first, and it needs to be completed from left to right. So 7 will be adding 2, 54 divided by 3, which is 17, and take that 17 and multiply it by 2 to get 34. And that 34 again is coming from this division multiplication from left to right. Now we add 7 and 34 together to make 41. It helps to bring our PEMDAS sign along with us, keeping in mind that multiplication and division and addition and subtraction can go from left to right. So bringing this sign along with us at every problem until we get really good at it. So let's take a look at number 2. It looks like we have subtraction, we also have an exponent number, we have multiplication, and we have addition. So if we take a look at our order of operations, I have to make sure I take care of that 4 squared first because he's not really a 4, he's a 4 squared. So let's handle this scenario first and rewrite the problem to be 24 minus 16 times 3 plus 15. Now it was agreed upon in the order of operations that multiplication would come before subtraction and addition. So I need to take care of the 16 times 3. That becomes 24 minus 48 plus 15. And that was because the mathematicians agreed that multiplication would come before addition and subtraction. Now, we are going to add and subtract, but we are going to do it from left to right because they are on the same level in the order of operations agreement. So, 24, take away 48, which is the same as 48 minus 24, but with a negative. So let's subtract here. It's going to be negative 24, and that's going to add to 15. Negative 24 plus 15 is the same as 24 take away 15, but with a negative on it because this one's heavier. So let's subtract, and that answer is going to be negative 9. We see now why it is important for us to be proficient in our work with integers as we evaluate expressions using the correct order of operations, because we have to be able to not just know the order, but also be able to perform the operations correctly with positive and negative numbers. In this next problem, if we take a look at all the operators, we have a 9 squared. I should probably handle that. We have division, and we have the absolute value of negative 18. So, things that we need to take care of first. We want to take care of the 9 squared, and we want to take care of the absolute value of negative 18. These are numbers that are written in a different format, so we have to put them in their actual value format. So 9 squared is 81. That adds to 28, divide by 4, minus the absolute value of negative 18, that's positive 18. So these were what I like to call numbers in disguise. We had to actually write their real values down before we can proceed with anything else. Next, you see addition, division, subtraction. So, according to the order of operations agreement, we have to divide before we can add or subtract. 81 plus 7 minus 18. Next, we will want to follow the order of operations and add, subtract from left to right. So 81 plus 7 is 88. Take away 18, that's going to be an answer of 70. In this next example, we have quite a bit of operators. I see that I have 2 sets of exponents. I also have one of the exponents inside of a parentheses. So my eyes are coming over here to this parentheses to make sure that this value gets taken care of. Inside that parentheses, I do have to take care of this exponent before I can subtract it with 29. I can also take care of this exponent because that's not really a 6, it's a 6 squared, so we want to make sure we say its appropriate value. So I'm going to take this one step at a time. Let's start by finding 2 to the 5th power. 2 multiplied to itself 5 times is 32. Since this is by itself, I'm going to go ahead and express it as its real value. It's a number in disguise. I'm really going to express it as 36. Now we can do 48 divided by, we can finish up this parentheses, so I'm going to drop the parentheses actually, because once I find the answer to 32 minus 29, the parentheses have done their job of telling me to focus here. So 32 minus 29 is a number 3, and then we could, or is an answer of 3, and then we can bring down our plus 36. Once we've finished fixing the parentheses and we've finished with this number in disguise, I see that I have division and addition. So I'm going to take care of the division because division does come before addition in the order of operations agreement. 48 divided by 3 is 16, and we'll add that to 36 to get an answer of 52. In this next example, we have parentheses in multiple places. First, notice here that this parentheses is being raised to the third power, which means whatever this comes out to is going to then be raised to the third power. In the second parentheses, you have subtraction and multiplication. Multiplication must come before you can subtract. So let's start taking care of these operators. 9 minus 5 is 4, and that's going to get raised to the third power. Here, 18 is going to subtract with 12. Notice how I took my time to analyze what the operators were and follow my order of operations, which I lost my little guy, so let me put him here for you. Now we want to take care of this exponent of 4 times 4 times 4, which makes 64. That's going to subtract with the value in this parentheses, which is 18 minus 12, also known as 6. 64 take away 6 is 58. In this last example, we've got quite a few operators. My eyes are coming over here to the parentheses, and inside this parentheses, I have a number in disguise, 3 to the 4th power, which I need to take care of. I also have another number in disguise, which is the square root of 16. So let's go ahead and take care of those first. 7 plus parentheses, 53 minus 3 to the 4th power, which is our first number in disguise, is 81. And that's dividing by the square root of 16, which is another number in disguise, which is 4. I have to finish cleaning up the parentheses before I can do any of these outside operators. So 7 plus 53 take away 81, which is the same as 81 take away 53, but it will be negative. So let's subtract. Okay, that's going to be negative 28, and that's dividing with 4. Now notice how I kept this in parentheses because it was negative 28 and I already had a plus sign there. So I wanted to keep this negative number inside parentheses so that the plus and the minus would be kind of like separated from each other. Now you can see you have addition and division. So we have to take care of the division first. 7 plus negative 28 divided by 4, which is negative 7. And 7 plus negative 7 is the same as 7 minus 7, double sign. And that is equal to 0. Now that you have taken really good notes and listened to all my steps on how to do these problems, we will do way more practice in class on how to work with evaluating expressions following the order of operations. Thanks for watching.